Hey, it's Nick from Greyscalegorilla, and in this tutorial, we're going to talk about the new render settings in version R15 of Cinema 4D. They updated a lot of the global illumination settings, and it's drastically different than a lot of the other, from every other version before that. So I figured in this video, which I know I've said I was going to do for a while, and so finally I'm doing it. In this video, we're going to go into some of these new settings for R15 and see what the differences are, what the changes are, and how to apply them to your scene. So let's head on in and let's get started. So I built a few scene files that should illustrate some of the new ways to set up global illumination. And I'm also going to go over some general good practices for global illumination in general. And then we'll talk about some of the changes in R15 as we see them. So here's the first scene file, and I set it up in a way that hopefully will show some difficult ways to, some difficult global illumination problems. And then we'll see how we can go along and try to fix them. So first of all, let's render. And you can see we don't even have global illumination on. And the scene is a bunch of these bars here and then one light source. I have this light bulb model with a luminant material on the actual light bulb. And then I have this reflective sphere, mostly to see what else is in the scene. And then we have these blue kind of discs just to like reflect some light and to start to see some of the settings. So let's first of all go into render settings and turn on the new global illumination in R15. You're going to see it's a lot different than you may have seen in previous versions of Cinema. So the first thing to notice is, or the first thing to know is that the Irradiance Cache algorithm is totally rebuilt from scratch. And you can actually see in here, there's the Irradiance Cache Legacy. That's the old version of Irradiance Cache. Then we have the new one, which the new one does a lot better with, first of all, with animation. So you could actually render with animation with Radiance Cache, which was pretty difficult before. It's also seems to be a lot faster and a lot more accurate. You get better contact shadows. And so let's just see what that is all on its own. So just default settings. We haven't changed anything. Let's do a render to the picture viewer. And you're going to see it render. And you're going to see, first of all, we don't have a lot of light. So the first thing we'll need to do is go into your illumination material. In the luminance material, you're going to see it set to, like, you could turn this up or down depending on how visually bright you want it in the scene. But what you really should do is once this looks bright, what you really have to do is go down into this illumination tab and adjust it here. So let's just crank it up like 10 times brighter. Do a render, and you can already see while it's calculating that it's a lot brighter. But holy crap, that looks like you know what? And what is going on here? Well, if you're using a luminant object as your main light source, what you have to do is turn on this right here, GI area light. And this is in the illumination tab. You turn that on. And what that's going to do is it's going to treat that light source not just as a random light source, but as an area light, as if you were to like make an area light here or use like the Light Kit Pro soft boxes. Like as nice as those look, you're going to get that from an illuminant object. And it's basically telling the GI calculation to pay more attention to this as a light source instead of just being random. You're telling Cinema that this is our main light source, or this is an important light source. Focus your energy on this, and it's putting more. It's looking more directly at it for these samples. So you can see the difference between this one and this one. It's only 1 second more on render time, and I'm rendering on a 12-core Mac Pro, just so you guys know my render settings. And this is a pretty small window. It's about 500 by 300. Something like that. And it's pretty small because I'm working on a smaller screen so you guys can see what the heck I'm doing. But you can see how drastically different that is just by turning on the area light. So make sure you're doing that if you're using luminant materials. And there's also portal lights, which are similar. They're set up a little bit different, and they're in the help menu if you look up portal. Those do the same thing. They tell global global illumination where to pay attention to. Because remember, GI works in a totally different way. It's not relying on kind of these default, old school 3D lights. They're relying on real light geometry and how light really falls off. So this looks a lot better than that, but we still have some problems. It's really splotchy. These bars here aren't really giving off a definite shadow. You could see a little bit of lines coming through, but they're not like big long rays of shadow. And that's really what would happen if with a small light source. These would be very defined lights. So what do you do to change that? Well, and again, a lot of this has come from the help menu. It's been a big help from me, and also talking to a lot of the guys that use this a lot at NAB and SeaGraph, and see how people use this stuff. There is this. There's a Radiance Cache, and then there's color refinement. And this color refinement basically says pay more attention to the shadows. That's kind of how I've come to understand this color refinement, which is a weird name. Maybe it does something else with color. But let's just turn it to 100% and do that render again. And you're going to see even in the pre-render here, you're seeing much more defined shadows coming from this light bulb. So let's check our render times. We got 5 seconds here. And much longer render time. It took double the render time. But you can see that's the result that I expect. And that's the more realistic result is these bars. I'm just jumping between the two here. Those bars get these really nice long shadows. So, maybe we don't need 100%. Maybe we can get away with 50. I don't know. Maybe we have to always balance, our render times with our quality. So let's just turn this down a little bit and see what, it's getting a little mungy again. So, play with that and understand what that does, which to me kind of sharpens the shadows, gets them more realistic, and pays more attention to the shadow detail. Okay, so those are all great. It still seems a little bit dark. Let's turn this up to maybe like 2000. Do another render here. You can see it's a lot brighter. And one reason I'm cranking up the brightness is we're going to start to talk about the secondary light settings, the secondary bounce settings. So in your render settings under global illumination, we have our primary method and then our secondary method. And while I'm looking at it, just so you know, you can twirl these open and turn these up or down. If you want this to be brighter, you could turn it up. If you want less saturation in your colors, you could turn that down. And also in your secondary method. Right now we have no secondary method, which means each kind of like global illumination works in a lot of really complicated ways, and I don't want to say I definitely am not smart enough to understand how the heck all this stuff works. Very smart science people made this work, and I talk in layman's terms in how I think it works, and the concepts behind GI that kind of help me decide what to do. So GI in general is looking at each pixel here and saying, okay, how bright is this pixel? How do I know how bright this pixel is? So it's going to say, okay, well, let me look at that area light. We told Cinema to say, hey, this is a light, okay? GI area light. So Cinema now knows that this is a very important light source. It's where a lot of light's coming from. And Cinema is going to look at this pixel here, let's say, and say, how bright is this? Well, okay, I have visible kind of contact from this point in 3D space to this light. I can actually see the light. Well, that's good. How far away from the light am I? Well, I'm this far. And then what should my color be? What's my material color? What's the materials around it? We're going to talk about materials around it later, and that's like a second bounce thing. But in general, it's going to say, if this were a real scene, if this were a real light, what color would I be? And then these darker shadows, right? They're looking at the same thing and they're saying, hey, what color should I be? And in this case, this particular pixel says, I'm not visible to that light. I can't see the light from where I exist in the world. Well, I must be darker, right? And this is, again, very rudimentary. Let's take this, for example. This pixel definitely can't see the light, not even close. It's got this big sphere in front of it, And it's not looking at that, right? And this is way too oversimplified, but remember that this is how this is happening, but we're only getting one bounce, essentially. We're only getting one look. And as you know, in real life, these wouldn't be as dark, and neither would these. The light would actually bounce off the wall that is behind the camera. You can actually see the wall just a little bit in this sphere. And the light would actually hit the wall and bounce and fall into these objects. And that's what this secondary method is all about. Okay, so Irradiance Cache, that's great. If you want it to be brighter, you could turn up the Irradiance Cache, and that's going to do a lot of help. But it's still only going to be one bounce, and it's not ever going to make this shadow any brighter because it's just not calculating any further than, do I see the light source or don't I? Okay, so now let's talk about, let me turn that back down a little bit. I kind of like it bright, but 200 seems right. And I'll just do a render in the background while we're setting this. The secondary method talks about the bounces. What's going to happen after this first very important method, which is probably the most important to get your main shadows and stuff. But then what happens to the light? Well, this is where the secondary method comes in. And this is where a new thing you could use pops up. So light mapping is brand new in R15. And I talked a little bit about all this stuff in my CGraph presentation this year, and talked a little bit about light mapping. I think I've learned a little bit more about it as I've played with it for a while now, but this is how I understand it. So light mapping is a fast way to get a lot of bounces in your scene. In fact, the maximum depth is set to 16 by default, which is like, okay, if we look at this pixel, how many bounces do I have to look to find and see that there is a light source in the scene? So if you take this edge of this ring, for example, let's say it looks out and hits the wall, right? And then it comes back and it bounces off one of these bars, and it bounces off another wall, and it just never sees a light source. Well, what happens? Well, it's never going to get lit, right? So in one way, they can actually look at this wall. This wall is lit, right? This ceiling is lit by this light. And the wall behind us is lit by that light. All these things allow this pixel to look in the world and say, hey, there is light to hit me. Allow this light to come hit me. And that's what this light mapping is doing. So let's turn it down for now to like 3 or 4. Something normal back in the day, like 2 or 3 or 4 bounces was kind of the limit of GI before your render times just went crazy, right? And so let's just do a render with 3 bounces. So here it is with just Irradiance Cache. And then here it is, still rendering, I guess. Shouldn't take too much longer. So we have 11 seconds on the first one, and the second one is 17 seconds. So not quite double, but definitely longer. And you can tell an immediate difference between this and this, right? This is how, this is still kind of basically really contrasty. There's no way to let the light kind of fade and bounce around, and this starts to look a lot more realistic. You could see, this scene's a little bit gray and whatever, and we can make it look better, but you imagine those really nice renders with like couches on wood floors and light coming in the windows and all that stuff. This is how they get that look. Multiple bounces, having light come in and spread along the room in a realistic way. So now you're looking, and we're getting some really, really nice stuff. We have contact shadows on this sphere. The sphere is like, hey, I'm touching the ground here. And it's less likely for this pixel that's really close to the sphere to ever see light than it is for this pixel. And it gets brighter as it comes out. We get a nice contact shadow without using ambient occlusion. Same with our kind of disc things over here, whatever these are, rings. We're getting a really nice contact shadow. We still have our long shadow from our main light source, but it's being filled in by all this stuff around it. And this light mapping depth can go crazy. So let's go to 20. The last one was 3 bounces, and you're going to get less and less as you go up. It's not going to be a linear thing. The more the light bounces around, the less intensity it has and all that stuff. So this is kind of a volume slider in a way to let you know how bright it could be. And in fact, it is about the same. It is exactly, it's actually faster. And that might be because it's being cached, but we have roughly the exact same render time with a much brighter fill kind of light. So, okay, so how do we make this look better? I'm seeing in the render we got kind of some splotchiness under here in the shadows, and a little bit of kind of grainy contact shadows here. So where do we go from here? Well, the main thing to make your global illumination look better is right here. It's this samples tab. Right now it's set to medium. I never like the percentage of samples. What I really like is the custom sample count. Custom sample count gives me some really accurate ways to dial this number up and down very directly. So let's just leave it at 64 and see what that does for render times and see what happens. So that slider really gives you the ability to turn up and down the quality very, very quickly. So you can see 64 samples is roughly about the same as where we were. It's much faster, but in quality-wise, it's really not that different. But if we start cranking this up, let's say 200, and we do a render, all of the samples are going to be they're going to be tighter, kind of tightly packed together. It's going to be more accurate. It's going to look for the light in more places, and it's going to give us a cleaner but longer render. So now let's see between these two. Here's 10-second render with 64 samples, and here's 200 samples. So we're starting to clean up these little parts down here. Still not perfect, but a lot better. And you can see our render time does go up. I'll say this all the time, but we're always fighting between long render times and beautiful images, and trying to get the balance between those two things. So, we could turn this up to 500 and do some tests. So this is something very important. This is a kind of a general overall quality for both of these other things. We talked a little bit about our Radiance Cache settings. I'll turn this up a little bit. We have our record density, which is our overall density, but a lot of this still is driven by these samples. The light mapping, however, starts to get into some really interesting numbers. The path count and the sample size. So one thing to look at is if the sample size is big. So I made it 10 times bigger, and we do a render. You're going to see these samples are big, patchy chunks on the wall. See these big like hex kind of objects? Those are your samples. I think there's even a way to render those samples. You could say, show preview paths, boom, right? So let's do that and see if it'll render and keep those preview paths. Let's that was still rendering. You can see we turned up the quality. We're starting to get longer render times, and we're going to see what we could do to make this a little bit nicer. Yeah, we really cranked it up. See what we did? So we have higher numbers here. We have higher numbers in our color refinement, and we made our sample size larger, which should make this actually a lot splotchier. Maybe I'm thinking about this differently, but let's see. This actually looks really good compared to this. It should. It's over twice as long, but it looks like we lost some of our contact shadows and things like that. So really what we're doing is we want this to be smaller. The sample size is that patchwork again. So if we set this again and we start doing a render, you're going to see this patchwork starts disappearing. It starts to get very more linear for this or not linear. It's going to be a tighter pattern, which means it's going to give you a more smooth effect the smaller this number gets. Now, path count is kind of like, as I understand it, kind of like a caustics number. How many samples are we going to fire out into the scene to calculate our light mapping? So in many ways, the light mapping can can get a little splotchy, especially with animation. And this is the number that really helps get that count more accurate. So you could double this actually and get a lot more samples in the scene. It does get, again, render times go crazy. This is GI we're talking about. There's no quick magic bullet for this kind of stuff for GI, but these new settings give you a lot more control and are a lot more stable. So you can see, look at these nice little contact shadows compared to this. Each one of the poles has a nice little contact shadow there. And you can even see in the background right here, all around where the corners meet, that effect didn't happen before, not as easily. And this is kind of where AO, where ambient occlusion, really steps in to try to solve this problem. But you can see it's a lot less of a problem now. So there's your light mapping settings, right? So this is the general way I do this. I come in, I make sure the lights themselves are set the correct way, and then I start looking at some of these primary and secondary methods. Radiance Cache plus light mapping works very well for me in a lot of cases. In fact, there's some presets here that weren't in the earlier versions. Interior preview is a Radiance Cache plus Radiosity Maps. Let's just look at that. Check render times, see how this is. And we get a okay, decent render. Our shadows aren't very nice, very tight, but it's very fast. So 4 seconds, and that's what these previews are for, to get a really good idea. This next one is called High Diffuse Depth. This one includes the light mapping and some really low samples. You're gonna see some pretty quick render times for this as well. But we still get a lot of grain, a lot of kind of splotchiness compared to where we ended up with our final one. But at a third or a fourth, it looks like, of the render time. So these are a good place to start to actually check out different render settings and see what they do. So go click on one of these, and then click the render, and then go see what this stuff is set up like. Go see what it changes the numbers to. You can see now we have low samples. And let me talk about this before we move on. Hemispherical sampling, as far as I've read, should always be on. There's be checked. And discrete area sampling and discrete sky sampling, I have left on as well. And what these do is they focus more energy on those lights that you tell to be area lights. They also focus more energy on the skies, which is what we're going to talk about in the next scene file. So these, I haven't found a good reason to turn these off. If anybody knows exactly why we should turn these off, or in what case they become faster, let me know. There's also a lot of these sample settings inside of each one of these. So if you want your area samples, which is that light bulb that we set up, to be more to be a cleaner render, you can say only in the area samples should you put more sample counts into those area samples, because they mean a lot, right? So you can start to steer this ship the way you want with more control in here. So I haven't had to do that in many scenes. I also work with very simple, shapes and images and text, and I don't have super complicated renders. So this could be something where if you're having a really tricky problem, come in here and try to force some samples. So this is kind of the first setup. Okay, so you can see actually here it really turned down our path count as well, and that helped with our faster render times. So that is our first scene. Let me hop into our second one here. And the second scene is from HDRI Studio Pack, and this is the HDR rig set up with a big HDR in the sky. And then we're also using the seamless floor, which is built in a studio rig, to kind of calculate the floor, the shadows, and our backgrounds. And then we have these little just reflective balls so we can see what the heck's going on. So if I hit render, we have no GI, but we do have some reflections. And these reflections are what is in the scene. So the HDR is in the sky and it's waiting to light the scene. And this is the way I light a lot of stuff, using HDRI Studio Pack and HDRs to kind of barf out the light data from the HDR back onto our scene and make this look like it was lit in a studio. And you can see we have a big softbox up here, kind of up to behind camera left. And then to the right, we have kind of two other different color softboxes. And we can actually extract this light data onto our scene, first of all, by turning on global illumination. You need that. Let's go to just preview and set to just Irradiance Cache, just like we talked about earlier. Just turning on the basic Irradiance Cache and doing a render and seeing what happens. So you can see a very quick render. It's, still a second. We have some really nice things happening. We have some nice contact shadows. We have a little bit of light leaking here that'll be fixed when we start turning up the settings. But you can see we start to get the light data producing shadows on the ground. So similar to that last one, that this pixel is saying, okay, how many light sources do I see? What color are they? What color should I be? What color is the texture? What color is the floor? And then this starts to be made. So let's turn up our sample count, something a little bit higher. You're going to see instantly a lot more accurate shadows. You can see those shadows smooth out a lot. But we're still not getting that second bounce. And the same thing here, I'm going to use the same setup, light mapping. I'm going to turn down the light mapping just so it's not overpowering. But you can see the light mapping is actually picking up a lot of the blue from the floor. You're seeing that patchwork too I talked about, that kind of patchwork that produces those shadows. But check that out. Check that this render is great. It not only picked up all the light sources, so here's without the second bounce, and here's with. Okay, so let's talk about what light is bouncing around. Not only is the floor bouncing up light and making that blue, it's also catching the light from the spheres that are nearby. So you can see in the cracks, the light is actually bouncing off, let's say, the back edge of this sphere, and then hitting the front side of this, which makes it brighter. Right? The bounces don't only have to work off of like the floors or walls or whatever. They work on the object itself and within the object itself. But check out how realistic that process happens and how quickly it happens with light mapping. We did add 10 seconds to our render. But for stills, with complicated stills, we could start talking about minutes and even 30 minutes and hours for some very complicated rooms that are rendered with this technique, right? So 10 seconds, even in animation, is not crazy, right? So I set this up to show you mostly what these bounces do in a really visual way, and just to show you, if we were to set the floor in the HDR rig, if we were to change this to like a red color and re-render this, it's going to pick up the red instead. And if one of these spheres were a color, like a blue color or whatever, it would actually reflect that into the sphere. So check that out. All the colors happen to it. The light bounces around. It looks much more realistic. Compare this, which to me looks like, even though it's global illumination, it looks like more of a standard, 3D render. But compare that to this, where the light really starts bouncing around, start to get more of that like V-ray quality and really nice kind of like filled in gaps, with less contrast and really kind of lit scene, right? Contrast where there needs to be in the bottom, but not where it shouldn't be, right? Okay, so real basic setup. Also, our sample count is pretty high. We can get a lot more realistic, or we can get a lot cleaner with turning that up. So let's just jump into the last one and talk about animation. I know a lot of us do motion graphics, and in the past, I've always said, hey, and this is still true to a certain point, if you're doing heavy motion graphics, see what you can do without global illumination. Now, a lot of things changed. I've been saying that for a few years now, 4 years. A lot of things changed in those 4 years. First of all, new algorithms, new GI algorithms are popping up that are more accurate, less flickery, give you less problems, and are faster to render, right? And also in the last 4 years, we've been getting more and more cores, not so much faster chips. They've all kind of topped out at 3 gigs or whatever, but faster and faster core, or more and more cores. So in this case, I have a 12 core on my machine. A lot of computers are shipping with, 2, of course, but, even 4 and 8 inside a laptop. So it's getting crazy, right? And you have all this power. So GI is becoming, very capable to some of us that only have one machine. The GI with animation in the past, it required like a farm or days of rendering. And so now it's coming to the point where if you need it, let's start talking about what settings we can use to make it useful for animators. So I set up this scene. So this is using Transform. It's another one of our plugins that allows you to get really nice animation without keyframes and stuff. So we have a lot of presets. We have custom mode. I built this in custom mode where it just goes, hey, move around on your Y axis, move up on your Y axis, and then rotate around randomly and then come back down. And we set this up really quickly with these sliders here using Transform. And this is the reason I set this up is this is a pretty complicated or typical situation where GI fails in the past, which is there's a context shadow on the ground, and then an object will move away from that point, and in many cases that shadow remains. There were cache issues, there were just sample issues, and there were always workarounds, but this was a big problem with GI in the past. So I set this up to try to emulate kind of not the worst case scenario, but something difficult, and so we could talk about what we could do to make this better. Okay, so let's go to our render settings. Let me just start from scratch. Let me turn that off, and let's just pick a frame here where they're hanging out, and let me just turn the save off. There we go. All right, so it's going to render. Boom. Oh, it's rendering every frame. We don't want that yet. You know what? That's fine. So this is rendering every frame. This is the animation with no GI, right? We have no shadows, and it rendered pretty quickly. And you're going to see the difference now when we start turning on GI, that this whole thing took 9 seconds to render. But of course, there's no shadows. So let's stop talking. Who am I kidding? I'll never stop talking. Let's pick this interior preview. This is going to have all the checkboxes on that we need. Specifically, we need discrete sky sampling. Sky sampling, like I said before, is going to look into the sky object, which is part of the HDR rig, and look at that HDR to determine how bright pixels should be. Okay, so now let's just set this to current frame, just so we're not waiting for a whole animation, and see what we get. Not bad, right? Same as before. It's really pretty good. We got a little splotchiness there, and we're still only using the preview settings. Now, all these preview settings have matching high settings, which basically turn up the quality on all of these. So preview high diffuse, preview small luminance. We have matching ones here, but with higher settings. So preview is, again, to see your render quickly so you can iterate and change your lights and change your color and change your animation. High is when you do your final render. So let's click high and see the difference now, and also check the render times. This one was 1 second. This one was 5 seconds. So let's see the difference. First of all, I'm noticing much sharper shadows. So you can see in here it gets a little let's go to the worst one. All the shadows are here, but they're very blobby. They're all very kind of just round, and they're there, and they give you the impression of a shadow. But when we go to this one, you're going to see much sharper detail. So, for instance, the light that peeks through this and this cube here, or the light that just kind of comes from under this one, it's much more defined, as we go to this better render, right? So for 5 times the render time, we're getting much sharper shadows. And the most important thing is this matters a lot in animation, okay? You may look at these two things and say, well, this looks okay, this looks fine, and it only took 1 second compared to this, that's 5 seconds. But for every inaccurate pixel that you have in your animation, in other words, the least accurate, the less accurate your render, the more you're going to see those inaccuracies as the frame moves to the next one, right? So if we just theoretically look at this render and say, okay, this is 90% accurate to what the light would do. Well, in the next frame, it would also render 90% accurate, and the differences between those should be not noticeable. But let's say if this is 10% accurate, well, the next frame might give you, let's stop talking about it and just render while I jabber on here. All frames. Okay. The next frame might give you an also inaccurate render, which then you see with your eye, right? The differences between those two, renders as the frames play back into your eye results in the flicker, right? And this is the thing that has plagued GI with animation in the past, especially Irradiance Cache. Irradiance Cache, it would almost never use Irradiance Cache for animation because of these flickering problems, because of these accuracy problems. And in stills, it's a great way to do it, but in animation, you need even more and more accurate looks because you don't want the differences between accuracy on each frame to show themselves, which that will result in flickers. So here we have our very basic preview mode or preview settings, and honestly, this isn't so bad. This is only Irradiance, so let's look back at it here. Let's just show you what this is. This is our Radiance Cache, and then our secondary method is Radiosity Maps, which we didn't talk about, but this is part of the interior preview preset that really does a pretty accurate job, but there's still that flickeriness. So if we look in here, if we look in these spots, you're going to see some flickery, you're going to see some grain. Let me zoom in here like 200% and talk about some of these kind of spongy splots. I don't even know what to call these things. Look at these little pixels, these little dark and white pixels that just pop out of nowhere. Do you guys see those? I hope you do. Hope the resolution's high enough. I'm even going to zoom in again just to make sure we're all looking at the same thing. So see all these like little flickery things? That's what I'm talking about. This is a very different type of flickeriness than we used to have before. This is actually a lot more acceptable, but it's really not great. You can see a lot of it in here. These hard to reach places, where the light may hit or it might not. These are those places where these pixels are confused. Am I bright? Am I dark? Maybe one time it spits out a random beam and it hits a very bright light source, and maybe in the next frame it spits out a random beam and then it hits a very dark part of the sky. And this is where you start to get these inaccuracies, these flickering, right? Well, so how do we solve that? Well, we could go into our Irradiance Cache. We could use something like this interior high setting that is a lot more accurate. We can go into our custom sample count and start to crank this up. Let me turn off Radiosity Maps just so we're not paying attention to those at all. Just look at a Radiance Cache. We can go into our Radiance Cache color refinement and refine those shadows a little bit more and get sharper shadows, right? All the things we talked about before apply to the scene, but you're going to start to see longer and longer render times as we move on. So, now we're looking at this and we're going to see hopefully sharper shadows. We're hopefully going to see, and these render times are not bad. We're still looking at pretty low quality settings, but we want the minimum amount to get by. We don't want to over render. We don't want to take too much time. Let's zoom in. Let's see what we got. So this is still rendering, but already I'm seeing a lot less of those problems, And even these contact shadows are like moving with the object in a really nice way. These seem really accurate, and we're getting pretty good frame rates. Like we're getting it looks like every 5 or 8 seconds we get a new frame, which is not crazy. So, we have a little bit of grain happening, but this is a lot more stable from here than that last render, right? A lot less of those weird pixels that don't know how bright they are, a lot less of these inaccuracies, and these shadows seem to be a little bit sharper than they were. Like, look, check this one out. It's almost a perfect little square as it comes off the ground. This light is peeking through the cracks here and hitting the floor. This is a really, really nice new Irradiance Cache method that is part of R15 that has really impressed me a lot with this stuff. Okay, so what if you cannot get away? What if you absolutely cannot get away with a Radiance Cache? You're getting flickering, you're having problems. What do? Well, the old standby is QMC, okay? QMC is a more brute force method of rendering GI. Remember when I said, hey, what's this how bright is this pixel? Hey, how bright is this pixel? Hey, how bright is this pixel? Hey, how bright is this pixel? As I understand it, a Radiance Cache tries to average that stuff out, so it doesn't have to calculate every pixel in every possible direction and look at every possible surface and every possible wall. If it did that, it would calculate forever. Radiance Cache tries to look at the important bits and pay less attention to the not important bits and try to do it. QMC is like, dude, I'm just going to look at every pixel and we're going to figure out the color of it by really looking around, like for real. That's probably the most technical that I can explain how QMC works. But let's look at the options. So let's turn these sample counts back down. Let's look at just QMC and see what the differences are. So first of all, you're going to see a lot more grain. Okay, let's just do a quick test or like check between these two. So here's the last one that was not this one was not QMC. So here's the first frame. I'm going to set this as our A. Click. I'm going to go down. I'm going to set our first frame here as our B. Click. And then we have our AB slider. Okay, so A on the top, B on the bottom. So a couple things. First of all, we have the brightness is a little different. We can make up with that just by either turning it up in our HDR studio, turning up our brightness, or going in and adjusting our gamma, or going into our QMC settings and turning up our intensity. As always, there's 8 different ways to do whatever you want to do in 3D, but those are the ways. The other thing you're going to see is really a lot more grain. So you can see all this grain, and let me zoom in here, and you can really start to see the grain between these two. Let me find my pretty little line here. Okay. So no grain, almost none. Look at the face of that. That's a Radiance Cache. Here's QMC. Okay, so more grain. So that's not good. Well, what do we get by using QMC? Well, what we get is we get a more accurate shadow render. So you can see we have grain down here, but there will be none of that flickering, none of that weird gobbledy flickering, right? All we're dealing with now is basically how much grain is acceptable in your render, and you turn up and down your settings to get rid of more or less grain. And that's our trade-off with QMC. QMC is like, hey, none of that flickery crap. Don't give me all that. Give me all that guessing. But we're going to introduce some grain into it because it's so brute force that it's looking at every pixel in a different way. And we basically say, how much grain do we want? If we want less grain, we turn this up. Let's go to 1,000. Okay. Let's compare the render settings. This last frame here took 5 seconds. So let's see what this one takes. This one's still rendering at 10. But now we're seeing way less grain, right? So let's set this as B now. Let's set this as B, and look at our AB, which I don't know if we can. Yep. Okay. Here we are. Okay. So here was Irradiance Cache. Let's zoom in again. Fumbling around a little bit, guys. But okay, here's Irradiance Cache. And here's QMC. Check that out. So obviously we have a brightness thing we could fix, but the grain is almost gone. And that's where QMC, if you really need GI, you really need that look, QMC can allow you that look without any flickering problems, but again, introducing grain. So I moved to QMC when I can't find what setting in my Irradiance Cache that is making it flicker. I can't turn up my sample count enough. I can't turn up my smoothing enough. I turn up my record density, and the render times are just getting crazy, and I'm still getting flickering. Well, what do? I go back and I go to QMC. Now, you can still use QMC with light mapping, right? But you also have to worry about your light mapping settings and turning this up as you need, if you see flickering here, okay? So these are just a few things to keep in mind when you're working with global illumination. When you're setting up your scene, whether it's a still or an animation, understanding how all this stuff works helps kind of figure out what that is. So I'll say two more things before we go. I know this is running longer, but I'm trying to give you a brain dump of everything I've learned, because that's how this site works. I'm learning this stuff as I go. I'm no expert. I ask around and play with these settings and do renders just like we did today, and A/B test and check render times. And I've been doing this since 15 came out, and basically have some go-to ways to try to solve these problems. And I want to share that with you guys and give you guys all basically what's in my brain, so that not everybody has to go sit and do all this A/B testing all day. They can just kind of listen to this and get some ideas and start to know where to play around with this stuff, really. So I'll say two more things. The help menu is awesome. Remember that when you're in your render settings, if you right click on hemispherical sampling and you go show help, it's going to go to that part in the dang menu and you can read about it, right? I've learned so much by looking at this. Check out this image. They got, okay, here's how the light is like bouncing around, and here's the difference between this setting and this setting. Oh my gosh, we got grain in this one. Ton of data here, right? It's hard to like sit and read the whole thing at once, but I've been learning a ton by looking at this stuff, and it's right there. It's for free, and you could just right click and go to that part of the menu. The other thing I'll say is out soon, if it's not out already by the time you watch this, is the new version of HDRI Studio, which is how I made the backdrops and lighting for this scene and for this scene. And the reason I'm bringing it up now is because we have presets in the HDR which allow you to try to forget about all this stuff and start from a place that works. And that's what we've done, is put a lot of our effort and a lot of my effort in learning about all this lighting into some really nice presets that allow you to start using this in your project without having to set it up every time. So, for example, we have some 11 and 11.5 presets. We have 12, 13, and 14 presets, and these are all low, medium, and high quality. We even have animation presets. So if we open that up, we have this nice little scene here, and we have some animation presets that are all ready to render and render very quickly. And this is all huge here because of my monitor, but you get the idea. Let me go 50%. That's better. But we got some really nice animation presets, and in the new version will be our 15 GI presets, which will cover a lot of stuff we talked about, but also give you a lot of ways to just pick an animation preset instead of having to set this up every time. We even have a physical animation preset, which include depth of field animation, the progressive render, a lot of ways to make your scene look as pretty as possible. and at least get you started in the right direction without having to set this up every time. So look for that soon if you're a current HDRI rigs user or HDRI Studio Pack user. You'll get this for free in your email, and we'll make a big announcement about it, obviously. But I wanted to kind of preview it for you guys. For those of you who stayed long enough to watch all this nerdy stuff, that we've been working hard on some new presets for our products. So anyway, thanks for watching. If you guys have learned something about R15 render that I'm missing that has helped you, drop it in the comments, and I hope this helps you make more beautiful renders. Thank you, as always, for watching, and I always appreciate it. I'll see you in another tutorial real soon. Bye, everybody.